This is the solution to question 3 from homework 4 in Physics 211. So here we have a more complicated pulley system. You may remember from the sneak peek question that the accelerations for these are not equal in magnitude. If this moves down by some larger amount, if this moves down by, say, 2 units of string, I need to get 2 units of string from up here, so I take one from the top and one from the bottom. So this idea from the sneak peek we're going to use later. All right, so the question just asks you to find their acceleration. So we do this in the same way that we do everything else. First we draw force diagrams. Now for M2, gravity goes down. The normal force goes to the right. And 2 different tension forces, well, they're the same, 2 copies of the tension force, I should say, act to the right. There are 2 strings, right? And each one applies a tension force to the right. For the hanging object, dropped my blue chalk. It's pretty simple. Tension goes up, and gravity goes down. All right. So now let's construct Newton's laws from this. To do this, I need a coordinate system. And you can pick anything, right? But for illustration, I'm going to pick kind of the conventional coordinate system again, where this is plus x, and that's plus y. So M2 in the x direction. I've got 2t equals M2 A2x. M2 in the y direction, well, let's stop and think for a minute. Nothing really interesting happens in the y direction. I'm just going to find that the normal force is equal to its weight. So this is boring. For M1 in the y direction, let's see, tension goes up. So T minus M1G equals M1 A1Y. So I've got my 2 non-boring equations here. But they've got 3 unknowns in them. So I'm going to think about the constraint. Right? A constraint is just a condition that says that one thing must move in the same way that another thing moves, or one thing must move in a certain way. Here I know, let's see, this one is going to move to the right half as fast as that one moves down. Or another way to say it is this acceleration, right, a to y, is going to be negative and twice the magnitude as a1x. So I can write a to y is the opposite direction and twice as big as a1x. Okay, great. So now we just do the math. So I've already got an expression for tension. Let's solve it for t. So this tells me that t equals, now I've got a factor of 1/2 here, right? 1/2 m to Whoops, I switched my 1s and 2s. I'm very sorry. Let's see, let me fix this. A2y, yes, I just switched my 1s and 2s. So the hanging one, the one moving in y is number 1. The one on the table, the one moving in x is number 2. So A2x. So now let me apply my constraint here. A1y is twice as big as A2x. So that means A2x is minus 1/2 A1y. So let's put that in. So 1/2 times a 1/2 is 1/4 M2 A1y. So now I found an expression for tension. So I'm going to substitute into this one, M1y equation. So that gives me the tension. So I have minus 1/4 M2 A1y. That's this expression I got. Minus M1G equals M1 A1y. Okay? Now at this point I just need to solve for A1y. So, actually, let me do something else to make this simpler. I know M2 is twice as big as M1. So I can write this M2 equals 2M1. Right? This one's twice as big. So that makes my life easy. I can say minus 1/2 M1, right? Because M2 is 2M1. A1y minus M1G equals M1 A1y. Now I can cancel an M1 from everything. That's nice. And just get rid of all my masses. And this gives me that A1y equals 2/3 G. Nope, minus 2/3 G. Right, which is what I expect because it's going downward. But that also means that A1x is minus 1/2 of A2x. Acceleration of the one on the table is minus 1/2 A1y, which is 1/3 G. So after all the math, just a few lines of algebra, I've got that the acceleration of this is 1/3 G to the right, and the acceleration of this one is 2/3 G downward. The big catch point, of course, for this problem is understanding the relationship between the two accelerations. Right? This was the hard bit, because we had to think very carefully about if this moves down, how does the string move to preserve its length?